This video is about complex solutions of quadratic equations. And we'll begin our notes by recalling, first of all, the quadratic formula, which is used to solve equations of the form ax squared plus bx plus c equals 0, where a, b, and c end up being numbers in our problem that we plug into this formula. As a reminder, the quadratic formula reads x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, as part of this quadratic formula, let's zero in on what's underneath the square root. And so if we look at only that piece, that's the b squared minus 4ac. That part of the formula is what's known as the discriminant. And that simply means it tells us what kind of solutions we'll end up with when using this formula. So if we temporarily use the letter D to abbreviate discriminant, then you have a few different options. First of all, D could equal 0. Now if D is 0, that means what's under the root is 0, but the square root of 0 is 0. That means you're actually only going to get one real solution. If D is positive, as we've seen in many examples, you'll end up with something under the root that, when reduced, will give us two real solutions. And thirdly, if D is negative, now imagine this, that'd be what's under the root being negative. Well, we have a way to handle that with the complex number system, which involves imaginary pieces. And so in the case when the discriminant is negative, we'll end up with two imaginary solutions. Let's look at a first example where we want to find all solutions. Notice all is specified. That could be real or imaginary. And the equation given is x squared minus 3x plus 3 equals 0. Now, in this case, we could apply really any method of solving a quadratic that we have, and note, because this is a quadratic equation, you could try factoring, try something else, but you might run into the point where we have to use the quadratic formula. I mean, you could complete the square if you love that process, but the quadratic formula is the shortcut to that. So we'll just start there and see how this ends up. If we plug things in carefully, we'll have x equals negative 3, that's negative b, plus or minus the square root of b squared, that's negative 3 squared, minus 4 times a, which is 1, times c, which is 3, and that's all over 2 times a, which is 1. Well, let's take a moment to start reducing this and see how it looks, which would be 3 plus or minus the square root of 9 minus 12 all over 2. And if we keep going, this could reduce to 3 plus or minus the square root of negative 3 all over 2. So notice in this case, the discriminant, which is what's underneath the root, ended up negative. Well, no problem, because we have a way to handle a negative underneath an even root, like a square root, and that's using the imaginary unit. So we'll rewrite this as 3 plus or minus I times the square root of 3 all over 2. Now at this point we can't get it any simpler because we cannot combine the 3 and the imaginary unit in the numerator. So we can just leave it as is, but notice this is what we would call an imaginary or complex solution to this quadratic equation. It would not be considered a real solution, but if we're asked for all solutions, then of course these would count. Let's look at a second example where we want to find all solutions. This time the quadratic equation we're given is not in standard ax squared plus bx plus c equals 0 form. Rather, this one reads x minus 3 in parentheses all squared plus 25 equals 0. Now, as you might recall from previous lessons, this would be a great opportunity to use the square root property to solve this. And so let's attempt that first by subtracting 25 from both sides, which will give us x minus 3 squared in parentheses equals negative 25. Then we'll go ahead and use the square root property to unsquare or square root both sides. On the left, we'll have x minus 3, and on the right, as we know how to reduce by now, this will turn into plus or minus 5i. Now we still want to get x alone, and we can do that by adding 3 to both sides. So we'll get x equals positive 3 plus or minus 5i. Now there's no way to combine 3 plus or minus 5i, so we'll leave it right where it is. Notice these are imaginary or complex solutions to this original quadratic equation as well.